All right, so the last two special segments we're going to talk about are medians and altitudes. The first one we're going to discuss is a median. So a median is a segment, and it's going to extend from a vertex, and then it's going to go to the midpoint of the opposite side. So let's draw that. Let's look at our triangle over here. Let's call it triangle ABC. We're going to say, all right, let's find some midpoints. So those are midpoints. Let's make them midpoints by cutting the sides in half. So now, to construct a median, you go from a vertex and you go to the midpoint of the opposite side. So if I start at vertex A, then I want to extend down to the midpoint of the opposite side. That's a median. From vertex B, all the way to the opposite side to the midpoint. There's a median. And from vertex C, all the way to the other side to the midpoint. So those are all medians. The medians of a triangle are all concurrent, meaning they all meet up at a point that is called the centroid. The centroid can also be described as the center of gravity. So if you were to hang a triangle from one point on the interior of the triangle so that you wanted the triangle to hang from the ceiling perfectly parallel to the ceiling and the floor, you would have to hang it from its centroid, the center of gravity. Now, what you can do on a coordinate plane is that you can actually find the coordinates of the centroid by drawing all the medians. So if you were to see here, they've already found the midpoint in V, that's 5, 2, and the question wants us to find the coordinates of the centroid of this whole triangle. Well, to draw the other medians, we first have to find the midpoints of all the sides. So to find the midpoint of side RS, remember the midpoint formula again, where you're going to add your x's and divide by 2, and add your y's and divide by 2. So if we were going to find the midpoint of side RS, right, we'd have to go, okay, there are my x's. I'm going to divide that by 2. Y's divide by 2. This is 7 divided by 2 is 3.5. 9 divided by 2 is 4.5. So there's your midpoint. Go over 3.5. 1, 2, 3.5. Up 4.5. So now we can construct the median from vertex T. So from vertex T to the midpoint of the opposite side. Now we can do the midpoint of side ST. All right, add the x's. That's 5 plus 8, and divide that by 2. 5 plus 8 is 13. Divide by 2 is 6.5. Add the y's. 8 and 3, that's 11. Divide by 2 is 5.5. So over 6.5. Up 5.5. Now we can construct our other median from R all the way to the midpoint. So you can see that right there, there's the centroid. They're all meeting up at point 5, 4. Now for the altitudes. All right, the altitude of a triangle is the perpendicular segment and what happens is it comes from a vertex as well. But the way that it extends through the triangle is that it's extending to the opposite side so that it's going to be perpendicular to the opposite side. So it's a perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side. The altitude is also known as the height of a triangle. So like when you're doing, area of a triangle and things like that, where the formula is base times height divided by 2, the height is actually the altitude. So here are some examples. When you have an acute triangle here, then the altitude lies on the inside of the triangle. So this is what it's referring to when it says from a vertex perpendicular to the opposite side. So it's starting at Q and it's dropping straight down so that it's perpendicular to PR. Now, when you have an obtuse triangle, the altitude actually lies on the outside. So see what happens, since we're starting up here at Q and that we have to drop straight down, this actually is not a side of a triangle, but it's dropping straight down to the line that does contain the opposite side. So that's what that second part of the definition is referring to, is that if you were to extend this side out as a line, that altitude would be perpendicular to the line that contains that side. Now, in a right triangle, the altitude is actually on the triangle, because this is the height right here. If you go Q, P, R, this is the altitude. So a right triangle, remember the legs are perpendicular in a right triangle, and altitude is perpendicular to the opposite side. So actually Q, P, here could be your altitude, or you could also consider PR as an altitude. So in a right triangle, you actually have two altitudes because of the definition that it extends from a vertex and that is perpendicular to the opposite side. Now we also have some special cases that in an isosceles triangle, the perpendicular bisector, the angle bisector, the median, and the altitude are all going to be the exact same segment if they're extending from the vertex angle. So from the vertex angle to the base are all the same segment. Because watch, so if I were to draw a perpendicular bisector in an isosceles triangle, from the vertex angle, there's perpendicular, and it's bisecting. Remember up here, this is the vertex angle. So in an isosceles triangle, the segment is only going to be the same segment if it's extending from this vertex angle. If you were to draw a median from the vertex angle to the midpoint of the opposite side, see it's on the same line. An angle bisector, if I draw the angle bisector, it's still on the same line and it's cutting that angle in half. So all of them end up to be on the same line. Again, altitude, so from the vertex angle straight down so that it's perpendicular to the opposite side. Again, all the same segment. Now, in an equilateral triangle, remember equilateral means that all the sides are the same. What happens is that these special segments are all going to be on the exact same line no matter what vertex you're extending from. So this is true for the special segment from any vertex. So what that means is if I were to come from this vertex and down, that the perpendicular bisector, the angle bisector, the altitude, the median, they would all be the exact same segment. Same thing if I went from this vertex over, all of those special segments are going to end up on the same line. And the last one, you can go here. Again, everything, the angle bisector, the median, the perpendicular bisector, and the altitude will all be the exact same segments from any vertex in an equilateral triangle. So now let's see this to use with some examples. Number one says D is the centroid. All right, so here's our centroid. So what types of special segments are inside? Well, if D is the centroid, all of the medians meet up at the centroid. So if AC is 12, then how much is AF? Well, it is 6 and FC is 6. And the reason I know that is because a median connects midpoints. So that makes F the midpoint. What about if BG is 6? Well, if BG is 6, then AG is also going to be 6 because of the same reason. G is a midpoint. So then BA, the whole thing, would be 12. What about expressions? Okay, well, AG is now 3x plus 78, and BG is 12x plus 6. Well, the way you're going to solve for x is because these things are congruent, because G is the midpoint, so you're going to set them equal to each other. Because you have both of the pieces along the side of a triangle, so if you have both of the pieces, they are congruent, they're cut in half. So set equal and then solve for x. So 9x is equal to 72, x is equal to 8. The question is find the length of BG, so we have to take that 8 and plug it back in right there. So that's 12 times 8, and then we're adding 6, and so our outcome is going to be 102. Okay, what about number 5, BC? The whole thing is 8x plus 16, and then they gave us BE is 2x plus 16. Now again, you want to make sure you pay attention to what pieces did they give you. BC is the whole side, and BE is half of the side. So remember, just like we did in mid-segments, that the whole thing is equal to twice the half. So you have to double the little piece before you can set it equal to the whole thing. Distribute your 2. Then we're going to go through and solve. So subtract 4x. So 4x plus 16 is equal to 32. 4x is equal to 16. X is 4. The question is find the length of EC. So you've got to take this 4, plug it back in right here. That's 2 times 4 is 8. 8 plus 4 is 24. Well, since BE is 24 right here, then EC is also 24 because E is the midpoint. So those are medians. Now let's look at an altitude. If WY is an altitude, then it wants to know which ones are the right angles. Well, if this is an altitude, altitudes are perpendicular to the opposite side. So we have 2 right angles there. We have YWX. So remember, you name an angle with 3 letters. So we have angle YWX. We've got to make sure that W is in the middle because it is the vertex. And then you have the other side. You can go YWZ. There's also a right angle there. So the other right angle is YWZ. Now, in 7, it's saying, what if the measure of XYW, so that angle in there, what if it was 3x plus 45? How could you solve for x? Well, we just said up above that angle XYW is equal to 90. So you set your expression equal to 90, and you solve for x. Divide by 3, x is equal to 15. That's how you use an altitude. Altitudes are perpendicular to the third side. Perpendicular lines form 90-degree angles. So you set your expression equal to 90.